So in this experiment, we'll study about kinematic analysis, a working of lathe machine gearbox, that is machine tool gearbox, is already discussed in previous video. In this video, I will explain how to analyze this gear train in detail. So this is our machine tool gearbox, which is used for a kinematic analysis in a lathe machine. You can see here this gearbox is there, this gear train is there, and this machine tool gearbox is used to drive this lead screw and hence the tool post that already we discussed in previous video. Here we'll focus on a kinematic analysis part of a gear train. So this is our gearbox. First step in kinematic analysis is we have to find out which type of gear train is this. So if you see carefully, you can observe as this, let's say this will be input shaft and this will be output shaft. So input shaft is connected to a chuck while the output shaft is connected to a lead screw, and this is lever mechanism to operate, to join or to obtain a forward and reverse drive, as well as neutral position can be achieved, that already we discussed. Now let's say this is our gear 1. Actually here it is, this will be gear 1. In this case it is gear 2, this will be gear 3, it is gear 4, gear 5, 6, 7 and 8th. So there are total 8 gears in a gear train, as well as you can see here this shaft as well as this shaft consist of more than one gear. Hence the gear train that we consider is a compound gear train. So in this compound gear train, what we can find out, so in this compound gear train we can calculate number of teeth. That teeth table is also provided on lathe machine, or if not, then we can determine number of teeth. And once teeth are known, so first step is we can determine teeth on each gear. So after finding teeth, we can also determine central distance. So how we can determine central distance? We can take scale and let's say distance between, let's say this shaft and this shaft, so 1 and 2. Then we can find distance between 2 and 3 by using scale, let's say this distance. So by using scale, I can determine central distance between 1 and 2, then 2, 3, this is 2, 3. Then we can determine again a distance between 3, 4. Let's say it is between 3 and 4, nothing but 5. That is 4, 5 is same on a same shaft. So distance between these 3, let's assume it is parallel now. I'm drawing it here. So this distance I can determine. Likewise, we can determine distance between or central distance between each shaft. So 1, 2, then 2, 3, 3, 4. Actually 3, 4 is on same shaft. Then 7, 6 is on same shaft. So distance between these two also we can determine. And finally, distance between the shaft 8, let's say it is here somewhere. Okay, I will show here. So this distance between shaft of gear 6, 7 and gear 8. Likewise, we can determine central distances. So first, as observation part in kinematic analysis, we can determine teeth on each gear. We can determine central distance, as well as we can determine speed. How we can determine speed? If I fix tachometer on this shaft, I already explained in previous video, you can see that where is arrangement to attach the tachometer. So on another side, we can fix tachometer on input shaft. So on another side of this shaft, we can attach a tachometer and we can find input speed as well as when it is in motion, as well as we can determine output shaft RPM by attaching tachometer to this shaft. Means what is my observation here? I can determine speeds by using tachometer. I can calculate teeth on each gear. I can calculate central distance. And once this teeth, central distance, speed ratio is known, then we can determine next parameters. Now, which are the next parameters that we will discuss? Okay. So actually, as a manual part, I already drawn this. So this is our gear train we discussed in the previous session. Now here we can determine teeth as already it is calculated here. So we can determine teeth on each gear. Then we can determine central distance. Once teeth and central distance is known, I already told you how to find speed ratio also. So first we can determine speed ratio, that is actual speed ratio between input and output. After speed ratio, finding actual speed, we can find out theoretical speed as the given gear train was compound gear train. So by using formula of compound gear train, that is product of number of teeth on driven upon product of number of teeth on driver, we can determine speed ratio theoretically. We can check the speed ratios. So first parameter we determine is speed analysis. Second, as central distance is known, teeth is known, we can determine module for each gear pair. Let's say T1 and T2, that is ABV or 1 2 we can say. So I determine module of AB, BD, DC1, whatever it is. So if central distance is known, teeth is known, by using this formula we can determine module. So once module is known, then we can determine piece circle of each gear by using basic formula, that is piece circle diameter is equal to module into teeth. Likewise, we can determine piece circle diameters, module, speed ratios as a part of a kinematic analysis. So this is all about kinematic analysis of a machine tool gearbox. Thank you.